We had problem 1, 2, 3, 4, 5, 6, 7, and 8 were all like the problems that we did the other day in class. Do we need to go through any of those? Number 4, fine. Perfect. Okay. So if we take number 4, where we have 3 to the 2a is equal to 3 to the negative a. And remember our diagram that we have. Okay, the diagram that we have that said, do we have the same base? Yes or no? Okay, all that. How many of you guys had that diagram copied down? If you do not get it copied down in your notes. This is the diagram that you guys will need. Well, we're gonna finish this one, but yes, we'll get to that. Yes. Okay.
I got.
Yo.
Do we have same base?
So, this is your diagram, yes.
No, I also have to.
Okay, so the diagram that we need to have so that we can work through these problems is, we start with the first question. Do we have the same base on both sides?
Yes.
Yes, okay. So our answer is yes, so what do we do? Look in your notes, don't look in your notes. What is it? What do you do if you have the same base? Set the powers equal to each other and then do what? Solve. If we don't, then we need to get them into the same base. And then once we have it in the same base, then we can set the powers equal to each other and solve. Okay, that's what we said the other day. Okay. Now this bottom part I added on today. So we'll get back to that in a minute.
No, wait.
Okay.
Say
Set exponents equal to each other and solve. Okay. So in this case, our first question, do we have the same base? Yes. So our diagram tells us that if we have the same base, what do we do? Set them. Okay, so I just look at the exponents and we set 2a equal to negative a. And we solved this. Now we're not done. We're not dealing with exponentials anymore. We're back in our last unit. We're solving simple equations. 2a and negative a. Okay. So now when we solve this, what side do you want to get your a's on? To the left. Fine. So I add a. 2a plus one more a gives me what? 3a. A minus a. The hard one. 0.
Yes.
Okay. What about okay. Now we have 3 times a is equal to 0. How do I get rid of the 3? Divide by 3. Divide by 3. What's 0 divided by 3?
0.
What about the 3 over there?
What about it?
It cancels out.
It doesn't cancel out. Remember, what does an exponential deal with? We have 3 times itself this many times. That has to equal 3 times itself this many times. Okay? So in order for these two to happen, we know that the value on the left is equal to the value on the right. It's 3 times 3 times 3 times whatever. 3 times 3 times 3 times whatever. Okay? Well, in that case, if I know I'm multiplying 3 times 3 every single time, I don't care about that. All I care about is how many times am I multiplying 3? How many times am I multiplying 3? Okay? Because those two values have to be equal. Yes.
For that problem, when I did it, I actually wrote no solution or 0 without the.
Those are 2 different solutions. No solution means that there is no number that works. 0 means that 0 is the only one that works. Okay, so don't confuse that terminology. Okay. All right. So any others 1 through 8? That's not 1 through 8. Okay. So
7.
Oh.
9.
9. So 9.
That's what I say to my dog because I speak German there.
Well, 7 is
That's interesting.
9.
Okay. All right. So for number 9, I'm going to write this a little bit bigger. We have 6 to the 3m times 6 to the negative m is equal to 6 to the negative 2m. Okay, what makes these different than the ones on the front page?
They're longer.
What do you mean they're longer?
Those.
They are longer, but they're longer how? How are they longer?
They have an end.
They have more stuff,
Oh.
right? They have more stuff there. That doesn't make them any different. It only makes them look different. So now if we look at this, what do you notice? We still kind of ask the same question. Do we have the same base? Yes, but wait a minute. Now take a half a step back. It's not solid, gentlemen. You guys asked about this. Okay, so here we go. We have the same base. We're multiplying. What do I do when I multiply when we have the same base? Add what? Add the exponents. So I keep my base, 6,
Oh wait, I think I'm understanding.
3m plus negative m. I'm adding these two exponents. I didn't change this guy, so I just carry him along for the ride. Nice. 6 to the 2m is equal to 6 to the negative 2m.
Yes.
Because 3m plus a negative m gives me 2m. This guy doesn't change. Now we go back to the question. Do we have the same base?
Yes.
Yes. If we have the same base, what can I do? Set the powers equal to each other. 2m equals negative 2m. And now we solve this equation.
So we divided, should we time the bases together?
Sure we did. We multiply the bases. But when we went through our properties, when we have the same base, we multiply them. What do I do? What's my property tell me to do? Add the exponent. So I keep my base and add my exponent.
The reason I also got a 0 for this one was like 6 and 6 is 36, and then I thought
6 times 6 is 36, but this is not 6. This is 6 to the 3m. And this is 6 to the negative. It's 6 times 6 times whatever. I don't know how many times it is. Okay, so be careful, don't fall into that. Yeah.
2 back 2 and divided by 6.
We have what? No, we go to my diagram. Do we have the same base?
Yes.
Yes. So now I set my powers equal to each other. I don't divide, I don't cancel it. When I have the same base, I can ignore the bases and only
But
concentrate
if you have,
on the exponent.
if you have different bases, how do you get same bases?
Ah,
Sometimes it's.
Well, then we have to
Sometimes
use
you have
our
to time
properties for multiplications and powers. We're gonna look at some of those. Now, 2m is equal to negative 2m. What side do you want your m's on? Left. So how do I move this guy over here? Gentlemen,
Thus,
gentlemen. That's fine, but you can take your conversation somewhere else because your conversation is becoming louder than mine. Okay, so let's not be rude. So we have this one. We add this one over, okay? 2m. When we add those, we get 4m.
m equals 4.
Negative 2m plus 2m. What do we get? 0. So now 4m is equal to 0. What's m equal to? 0. So m again is equal to 0. Okay?
Wait, so when the bases are the same, the answer was going to be 0.
No. It just happens to be that the first two problems we did, they both come out to be 0. 14? 10? 10. 10 is nice. 10 is different. 10 looks different. 10 is no different than 9. 2 to the x over 2 to the x is equal to, I shouldn't say it's no different. It is kind of different. Okay? But we still use the same property. Okay? Before I can set my powers equal to each other, I have to get a single base on the left and a single base on the right. Can I get these things into a single base?
Yes.
Yes. What are you doing with these bases?
Adding them.
Careful.
Divide.
What is this? We're dividing. When I divide the same base, what do I do with my exponents? Subtract. So I keep my base, I take my numerator minus my denominator.
Negative.
Okay, easy. This is going to be the second hardest question of the day. What's a number minus itself? 0.
0.
So now on the left, we get 2 to the 0.
That's 1.
Very nice. So 2 to the 0 tells us that it's 1. Now, you could have gone this route. Or you could have stopped here and said, oh, we got the same base. Well, if I have the same base, what do I do with my exponent? I set them equal to each other. So I could have done 0 is equal to negative 2x. Or you could have said, oh, 2 to the 0, that's 1. Well, what does that mean? 2 to what power is going to give me 1? 2 to the 0 power. Either way, 0 is equal to negative 2x.
That's the answer.
Not yet. We haven't found x.
So then, Mr. I don't get it. What did you put?
Yeah,
So 2x minus x and then.
Okay, we're dividing, right?
Yeah.
We're dividing the same base. One of our properties said, what happens when I divide my same base?
You said the exponents to each
No,
other.
no, this is for solving exponentials. My properties, the one that we did with just the other day, those 7 properties. Remember those?
Yeah.
Remember it now? So forget about this side. If I just have this, like on your quiz the other day, if I just gave you the left side, what would you do? You have the same base? Okay, so when I'm dividing and I have the same base, I subtract my x.
Yeah, but I don't get it.
Numerator
Why?
minus denominator.
Oh, never mind.
Same thing with this.
So if you
I'll just carry this guy all the way down.
First you x minus x and then you turn.
Right, so all we're doing to the right side is I'm just carrying this guy down because I haven't changed, I haven't done anything to it. I'm concentrating on the left side. Same base, subtract my exponent. X minus x gives me 0. So if this guy, okay, this guy comes down here, this guy goes down there. This guy just gets carried along all the way to the right. Because I'm not changing anything on that side.
Got it.
Okay. Now, 0 is equal to negative 2 times x. For the third time in the riddle, a coincidence, x is equal to what? 0. Again, this is just a coincidence. They don't always come out to be 0.
Is this 1 equal to 2?
1 is equal to 2 to the negative 2x.
And the other one 0 equal to negative 2x?
Because we're taking this property,
Where did you have the 0 from?
So they're different measures.
x minus x.
Wait, can we do 1 and 4?
So there's 2 ways to think about this. From here, we could have stopped because now we have the same base on both sides. Then set my exponents equal to each other and solve. Or comment came out, oh, 2 to the 0, that's 1. That's awesome. That is true. That's one of our properties.
Oh, yeah.
Now I have 2 raised to some power is equal to 1. What's the only possibility for negative 2x to be to change the base of 2 into 1? That power has to be 0. It's the whole power. So either way, we get to this point. Whether you saw it from here with the same base, or you saw it from here with something equal to
So
1.
when the no, so like when it's 1 equal to like 3, I don't know, like any of the numbers, it always going to be 0.
Yes. Yes. So that's the addition that I put onto the diagram from the other day. So the other day, we did not have this. Okay, we only had this top part. Now, because of, oh, yeah. I'm recording this, by the way.
Hey.
So as we see this, okay, do we have the same base? No. Well, we need to get the same base. Okay, so if we get the same base, like we have been, we go here. But in this case, it's no. Well, is 1 on one of the sides? Yes. Okay, if it's not, then we can change the same base. If it is, then I know my exponent is equal to 0. Okay, that's the easy part. Does that make sense?
1 and 4.
Hold on 1 second.
Agora entendi. Oh my
Okay,
God.
I just want to make sure that
Wow.
we understand this before I go on any further. Okay? So, do we have the same base? Yes. Set the base, set the exponents equal to each other and solve. If you don't have the same base, can we get the same base? If yes, set them equal to each other and solve. If one of the sides of the equation is 1, like we had in this problem, then we know that my exponent is equal to 0. That doesn't mean my variable is equal to 0, that my exponent is equal to 0.
So the X is very
I
few.
got it.
Right? So again, we're using this diagram to simplify the process because the process is the same every time.
Wait, so when it's equal, so the first one, when it's equal to 1, then you know x is equal to 0.
No, isn't the base 0 and then the.
No, these are just the exponents. This is just the exponent. Okay? So we try another one.
4.
4.
We already did 4.
You did?
I think so.
11.
Wait, Mr. Lisa, then say one part of
This
this method.
Yeah, you go different.
Like, here's the, it's one side one. and then-
Yes, okay, so is one side 1? In this case, one side is 1.
So that, like, it turns into like, no, and then the little like arrow.
If it's
goes.
not, then I can get the same base on both sides.
Oh, it's not.
But if it is, I know my exponent is 0. Okay, sorry, little explanation needed there. Alright. So, let's take a look at number 11. Alright, number 11. Alright, so 11 says that we have 10 to the negative 3x times 10 to the x is equal to 1 over 10. Now, I don't have a single base on the left side. Can I get it into a single base? Do we have the same base? In other words, can I combine these two things? Yes, because they're being what?
Multiply.
Multiply. When I multiply the same base, yes, absolutely. We add the exponents. I keep my base, negative 3x plus x equals 1 over 10. Okay? Well, now, negative 3x plus x.
Negative 2x.
10 to the negative 2x. Nice job. Is equal to 1 over 10. Now, we're back to one of the problems that we had in the first couple. Can I get this thing? In other words, we go back to my question. Are these in the same base?
No.
Not exactly. Try that. Can I get these into the same base?
Yeah. Because the negative of, if you, the way I found it is that negative 10 to the power of negative, no, sorry, 10 to the power of negative 2 is a decimal. And when you think about it, 1 to 10 equals 0.1. And then if negative 2 equals negative 1, if negative 2x equals negative 1, negative 2 actually, negative 1, then 10 would become 0.1.
Okay, so you convert these into decimals. There's an easier way to do this. Okay, where I don't have, that's good thinking. But I don't have to convert these into a decimal. What does that mean when I have a negative power?
Oh, you need a.
How big?
I flipped it, okay? Now, it works both ways.
Did you finish that problem?
Yeah.
That would be. Now, so what was to a negative power to get 1 over 10?
10 to the power of negative 2.
Yes. So if I have 10 to the negative 2x is equal to 10 to the negative 1. 1 over 10 is the same thing as 10 to the negative 1. Now do I have the same base?
Yes.
Yes. Now I can set these equal to each other. Negative 2x is equal to negative 1. Now what do I do?
Both are negative, so you can simplify them to positives.
Okay, so they both equal to positive, so 2x is equal to 1.
X equals 1.
X is equal to 1/2. Nice, it's not a 0, so we can get out of that half. Divide each side by 2, okay? They said, like I said, that both of them are negative, so if they're both negative, divide each side by negative, because it's a positive. And then divide by a 2, we get 1/2.
Well, I'm just good.
So we get this.
I was gonna ask the same questions, but I thought but it's they're the same thing.
Yeah, now, you could have also said, and I thought this was where you were going, with the negative 2x, if we have a negative 2x, we could have said, okay, well, then it's a 10 to the negative 2x, that's 1 over 10 to the positive 2x. You could have done it this way too. Okay, and then we say, okay, now this is the power of 1, you could have solved this one. Okay, so you could have used that negative to down there.
If the bases are the same, we'll divide them. Then it's that.
Ladies and gentlemen, I know it's Friday and I know you guys are excited because you have next week
Oh, yeah.
Wow. Next week, but you gotta pay attention, and some people are asking
But
questions.
actually, we're gonna wait
So
till
if we
like
have the same
7.
base, we will divide the base, and if we divide the base, if we are only to subtract.
If we are dividing the basis, if we're dividing the basis, we always subtract the exponent.
We just
If we're
divide the base.
multiplying basis, we always add it.
So when like we
When we have a power raised to power. Okay. So that takes care of 9, 10, 11.
14.
Should we do 12?
Right.
12?
Yes,
Okay.
12.
Yes, you should do 12.
All right.
Yeah.
Well, we can go to 14.
Before you join.
multiply.
What is math?
What
is life?
What
What's the meaning of life?
I got a lot of
I mean, yeah.
All right, here we go. All right, here we go. Let's settle down. So the question was, can we do number 12?
I don't know, can we?
So we take number 12. Number 12 is not unlike number 9. So we take 3 to the negative 2x plus 1 times 3 to the negative 2x minus 3 equals 3 to the negative x. So just like number 9, we got a product of the same base. When we have a product with the same base, what can we do?
You first add the two exponents,
Okay.
the two bases that are here.
We don't want to add the base. You're right the first time. Keep the base. And we add the exponents. So it's negative 2x plus 1 plus negative 2x minus 3. Okay? So I take the first exponent and I take the second exponent. Now, yes, you always follow the order of operations. Have we done anything to the right side?
No.
No, so he just comes down. Okay? Now, simplify this thing by following our order of operations. What's negative 2x and negative 2x? So 3 to the negative 4x, 1 minus 3. What's 1 minus 3? Negative 2. So now we've got the numerator simplified, the exponent simplified. This one we didn't have to do anything, so he's already simplified. So now we got the same base. So yes, we have the same base. What do? Set your exponents equal to each other. Do you see the pattern you're developing here?
Yes.
Okay, if you follow the pattern every single time, these problems become very simple. If you approach these problems because they look different, if you approach them as being different, you're going to try to create a different pattern every single time, and that's where confusion happens. Follow your processes, follow your properties. Do the things that you can do, and then do the next thing that you can do. Here, this is what we just did the other day. Same base, we're multiplying, add the exponents. That's why we did those properties first, so that we can attack these problems. Now, the next step is to take it not just in an expression, now we take it into an equation. Now we're looking at exponential equation. So now we want to get the same base. So we have the same base, set the exponents equal to each other. And now we solve. Now the beauty of this is we go all the way back to what we did in the very first part of the year.
Plus
Okay?
4 to it.
Okay, you want to add 4 to that side? Fine. Add 4x, add 4x. Negative 2 is equal to, careful, 3x, because that's a negative 1. Divide by 3. So, negative 2 divided by 3 equals x.
Would it be wrong if this are 100%? Like in the part that's 3 and 4x minus 2 has the 4x already to 3x here.
As long as you can keep all of this. I just don't write the bases. You absolutely can work on that. But what I want you to be careful is we are not changing the base, and we're not manipulating anything.
But
There's no reason to carry that base along.
no, like just instead of like doing this, just pass this forward already in this apart to here.
You're just doing this.
Yeah, but like, right, just to, oh, wait.
Because this deal is
Yeah.
only in the exponent. Okay, so we're only in the exponent. All right, so that's 9, 10, 11, and 12.
14.
14 is the one up on the next, huh? All right, here we go. 14. Ooh, 14 is nice. Can I erase this?
Yeah.
Infinite. No, Google means infinite.
No, Google is a Google.
No, but it means like
Google is a number.
that's why Google is a number.
Google is a number, but it's not infinite. It's very, I guess, if you look at that,
Mr. Can do 17 after.
what is it? Google, and it's actually Googl, not
Oh.
Google Google is, I can't remember, I have to look it up, but it's, I forget how many zeros it is. It's like,
It's 10,000. Or is it 10?
I can't remember, like a million zeros or something.
Million.
Okay,
After
So-
can we do
14.
17 or 18?
Yes, we did the 17 and 18. 6 to the negative 2x times 6 to the negative x is equal to 1 over 216. Now, we look for things that we can do. Yes,
My first combine the 6.
good. Same base, multiply. What can I do?
You add
Add it. So 6 becomes a power of, nice, equals 1 over 216. Now, we got 1 over something. Whenever you see that 1 over, what is that immediately telling you? Okay, so 6 to the negative 3x is equal to 216 to the,
Minus 1.
nice, very nice. We're getting these properties down now. Now, here's what we did the other day. We have a different base. Can I get 6 into a base of 216 or 216 into a base of 6?
260.
I think yes. that's
Okay,
good.
so if it's gonna be in a base of 6, start small. 6 times 6,
36.
36 times 6.
260.
It actually comes out to 216.
216.
So this one doesn't change. This 216 is now 6 to the third power,
So that equals 6.
but that 6 to the third power still has to be raised to the negative 1.
Oh.
Okay, so don't forget that. Now, here's back to your other question. Now I get a power raised to a power. What happens when I have a power raised to a power? You multiply. So this becomes 6 to the negative 3x is equal to 6 to what? To the negative 3. Now, our question becomes, do we have the same base? We got a single base on each side. They are the same. What can I do?
Negative 3x equals negative 3.
Negative 3x is equal to negative 3.
Divide by 2 is negative 3.
Divide both sides by negative 3.
And that equals, x equals 1.
X is equal to a positive 1. Very nice.
Whoa!
This is nice.
All right.
Wait, no, wait. Divided by negative 3. Divided by negative 3.
18.
18, we want to skip all the way up to 18?
No, yes, no. 17.
Okay, we do want to
Let's
get,
do everything. 17.
all right? I want to do number 15.
Oh, I want to do 15 too.
All right. All right, so 15. 2 to the x times 1 over 32 is equal to 32. Now, this one's a little bit different. What did we just say? Whenever we see 1 over, what does that tell us we can do?
It's what will be
Put it to the negative 1. So you got 2 to the x times 32 to the negative 1 is equal to 32. Sure
Wow.
wish I had a way to combine them.
Oh, but you do that.
Wow. Wow.
You
Why
change
can't
the
I?
negative.
No, you need to
But I
make
gotta
a
change it.
32 into a 2 or a 2 into a
Ah, can I get 32 into a base of 2?
I don't know.
Yes.
Probably
Try it.
yes.
If when you're ever in doubt, just start and start multiplying. What's 2 times 2? 2 times 2 is 4 times 2
8.
is 8 times 2.
16.
16 times 2.
2 to the
Hey,
power of 5.
2 to the power of 5. So 2 to the x times 2 to the 5th Well, hey, that's 32 as well, so I might as well change that one as well to the 5th.
Wow. Why does that have to
We are
be
so
right?
smart.
Ah, good question. Why does it have to be in the parentheses? Because this 32 is being raised to the -1, and 2 to the 5th is 32. Okay? So, in other words, I substituted 2 to the 5th into that 32. That -1 still has to be on whatever is inside there. Now, I write this simply because I don't want you to forget this. Because that -1, a lot of times, common mistake, we'll leave that off, we'll forget it. Makes a big difference. But now, power to a power, what do we do? Time. So we got 2 to the x times 2 to the new power is what? -5. Very nice. Is equal to 2 to the 5th. Can we put these together now? Okay, so we put them together. What do I do with the exponents? Add. So it's x plus a -5 or x minus 5 is equal to 2 to the 5th. Do we have the same base and single base on both sides?
Yes.
Yes. What can I do?
X minus.
Now you do exponential.
X minus 5 equals 5.
Add 5 from the negative.
Tough one. 5 plus 5.
10.
10.
15 squared.
X
I know that,
equals
dude.
10.
Oh my God.
But what about the negative?
What negative? This negative?
No. Yeah.
Okay, well, from there, we added 5 to move that over.
Oh, that.
I get confused like or add the exponent versus calculus.
That's why I made a big deal about, we did those 7 properties first, and then we took a little formative just on those 7 properties, because, excuse me, we're using a lot of these 7 properties in these, right? When do I multiply the exponents? When do I add the exponents? When do I subtract them? Okay, so we're doing those here. We're still using those 7 properties. Well, you saw with the x, right? So you gotta get the exponent itself.
Yeah, I see.
All right, so that was 15. Sure. So we want to go to 17?
It doesn't have to.
17 is, let's see if we can do 17.
Go.
I'll let you guys work through this. 64 times 16 to the -3x equals 16 to the 3x minus 2. See if you can get this now.
Real. The rest part.
Exactly what we did. Take a look at the one that we just looked at. See if you can get this. Okay? We got a 64, 16, 16.
Listen, we kind of do have the same base. Because we have 16.
Okay, so now the question becomes, can I get 64 into a base of 16?
Yes.
Almost.
No, no, you got
Because
16.
16 times 16 gives me how much? 256. It's too big. It's already bigger than that. So I can't do that. Okay? I can't do 8 because 8 times 8 is 64, so it's bigger than 16.
You get it to a base of 2.
Okay, we could do a base of 2.
You can also get it to a base of 4.
I could get it to a base of 4. Why can I?
4 to the power 4 cubed.
Nice. 64. She's so excited she can't talk. 4 to the 3rd power is 64. Okay? Times 16 is 4 to what power?
2.
Nice. I told you I was going to let you do it. I get excited. Sorry. 16 is the same as 16. We got 4 squared. All right. So I got you set up. See if you can finish it.
Eu queria umas 6 lá atrás. Dá pra ver. Vamos fazer mais pouco também. Tem que distribute pra cá. Né? Sim, ó. Tá vendo? It is -1 and distributed to 5 é negative 5. Mas aí fica, tipo, 4. Não, 4 são de negative 6x. Você carry down o x também. Mr. D, carry down the x. Not
Carry down
like
whatever we do.
distribute.
So let's see. Are you gonna do anything with this guy immediately?
No.
No, so we carry it.
Whoa.
What does this become?
4 to the negative
4 to the
6.
negative 6x.
The negative 6x. This one's the challenge. This one becomes 4 to the what?
Wait, let me see.
4 to the, wait,
Okay.
6x minus.
No, to the 3.
4 to the
So close.
3. 4 to the 2.
4 to the
4 to
3.
the 3x.
4 to the 3.
What do we do with these powers?
You
It's 0.
Multiply them. So we got 2 times 3x minus 2. What is that property?
X.
Distributed. So 6x minus 4. Not minus 2. Careful. Be careful. So now, what can we do?
You set the.
Whoa, we can't go here because I need a single base on each side.
4.
So,
You add the x.
put those.
3 negative 3 minus 6.
4, 3 minus 6x.
And you have 4 times.
Oh, I skipped a step in mine.
3 minus 6x minus 4.
Yeah, I
3 minus
skipped
6x equals 6x minus 4.
So you just do plus 6x from the
Okay.
right side to left side to the right side. So 3 equals minus 4, and then you plus 4 plus 4. 7 equals 12x divided by 12.
Keep going.
17 over 12.
7 over 12 is equal to x. Very nice.
Wait, Mr. I skipped a step.
Now, here's a little trick. I'm not even gonna say that. I don't want to confuse anybody.
Wait, that's
I'm not gonna
number
give you that.
15, but I don't like to be confused.
That one, this one is number 17.
I got a different answer.
Uh-oh, be careful. Let's check this.
What I did, I actually, instead of going simplify by 4, I simplified by 8. So I got 2 part of 6. And then my
No.
we skipped different step, the 4 over 3 times 4 to the 6x.
So we got 16. We can change that to a power 2 of 4, but we're not adding those.
Oh.
There's the power raised to a power 1. You definitely can change it to a raised to 2, but be careful. Power to a power 1.
In the formative, I didn't say a mistake in the beginning, went through the.
That's nothing.
Yeah.
Thank you.
Yep. All right, should we do number 18?
Yeah.
Yes, please.
I'm not gonna erase it. I promise. Yes, this one I want you to do completely by yourself.
No, mister.
Come
Rob
on.
just told me it's the hardest one and
It's
I
not,
barely can.
it's not the hardest one. You do get them.
I can barely do the
Understand.
I
first
got
one.
faith.
Oh, I don't miss that.
I got faith. Take it one piece at a time.
It's a fraction.
Oh my gosh, fraction.
Oh my god, I hate those.
You need one. I'm just gonna copy it over so you can see
No,
it.
you get it to a base of 3.
No. Oh.
I'm just gonna find out.
Someone
This is the problem at
unfollow me.
work. While you're doing that, I'm gonna take attendance.
I'm here.
I see that.
Thank you, Shane.
Physically or mentally?
I don't know.
You don't know. Well, that speaks volumes.
Mom, oh, we're supposed to do it. Mister, I don't know where even, I don't know where to start.
I can try.
This one will help you if, I don't want to say this.
I know
The way to solve this is, remember I told you that you had to be comfortable with fractions?
Yeah.
I know how to.
Get this right now, treat this. So the other ones we've been dealing with multiplication. It's okay, leave this as a fraction. What's that? Tell us how to start and I can finish. Okay.
No, don't. You need to tell us how to finish it. 'Cause I know how to.
Okay, so,
Wait, sir, I think I got the answer.
yes,
Do we like equal like 81 and 2 lines and equal 3, or do we divide it 1 and 2?
we can't divide this in there.
Can we take
Okay.
the denominator and minus it and bring it together?
If you multiply, then it's gonna be over here.
The only thing I analyze is that,
Minus
Okay.
5.
the only thing that I analyze is that.
Okay, wait, let me do
You can, I don't know how many of you guys heard that. You can multiply both sides by 243 to the negative n. And then you're kind of like back in a situation like that.
One of the problems is.
9.
And this is one of the more difficult problems.
Why, sir?
Why? Oh, if you think this is easy, that's perfect. That means you're getting great.
Well, they should have seen this. I don't know English. Yeah,
Wait, is there a common denominator?
We don't need a common denominator, but we could get a common base, yes. Yes.
We just read?
Okay.
Oh, wait.
Oh, my God. Yes.
Wait.
Then it's just.
You're writing so much exponents and like when I was like 243, I was
I'm done.
Okay, I did one
I don't
thing.
know the way.
Yes, you're not saying so.
I won't.
The closest I got was the part.
Shut up, please.
The answer is negative 2.
Guys, please.
Because you forgot to put.
I got,
Wait.
because there is a
18, right?
and 81 equals 3.4.
No, I just.
And then
Put the 2.
I added the
It's, no.
which I think that's
No, no.
Shows you how you do it.
And then I got 3 to the power of 4, 3 to the power of 5 equals 3 to the power of 2 minus 0.
No, hold on.
But, Jesus God.
When you're high up above or down below.
Please shut up.
Mano, bateu perto e bateu desespero, tá ligado? É esse problema que a gente viu no olho ali. Então você vai nu? Deus, I'm a Jew.
It is negative 4. Sorry, I'm still trying to summarize my time.
Mr. Teacher, I
I
have a question.
got this.
Yes.
Stay out. Stay out. That's it.
You have to memorize it.
Now what?
That's how you learn.
Memorize.
Learning is essentially memorizing.
I know that I have to look. Save and save. Well, I make like a book.
That's
So
all.
fun. So it's gonna be a CD ebook.
Reading
So
This side?
Yeah.
Not if you're messing with this side.
Unless
Or anything that.
But then it's like,
You
don't make
So like I'm lost, so I'm just yeah. I'm just trying things, and I try to find a numerator and
Not nine. So you can't get 3 into a basic number. So, alright, so you guys are,
I'm almost done, sir, please.
Yo,
maybe a little bit more.
Thank you.
Give me
Mr.
that.
I have a question. Mr.
This is a simple problem.
I thought it showed that 242 is 3.5 and 8 is the part
We need to get to the same.
I think it was a lunch. I got it. No, I flex.
Wait, Mr. I have a question. So, now this and then you get gold.
No, Maya.
Okay.
This, no.
Então vai dando vários meses.
Solve 21. Solve.
Here.
Awesome.
It's just right.
But I have no idea. Você viu de Samara? Yes! I'm gonna try. Mana, você foi embora.
Vai na vontade.
Aí eu posso trabalhar. Oh, so great.
So, dear,
Meu pai falou que ele
Oh my God,
ele falou que
I
ele
was
não precisa ter um 5 novinho lá na minha
I was here last.
É que eu não vi que ela teve que ajustar porque a bateria era
I got
ruim.
it, I think. She wasn't here last class. She didn't learn this Please be wrong.
It'll be
It's
wrong.
wrong. Tell her it's wrong.
No, it's right.
I'm winning.
She has too much
If
coffee.
you,
I know.
if you
I'm
agree,
sorry.
it's just a negative.
I
It's wrong, Mr. Easter.
fixed it.
It's right.
Shut
All right, here we go. What's the common base? Here we go. What's the common base? 9. I can change all 3 of these bases into a base of 3. So 81 to a base of 3 is what? 3 to the power of 4. 3 to the power of 4 to the 3n plus 2. 243.
Three for the third.
Just a question.
Three and a half.
And then you distribute. Oh, the bottom. But if you do your by 8
Negative 5n. That's 5n. Okay, now,
So happy.
Don't say that.
power to a power, what do we do? Which uses what what operation? Multiplication. What about down here? Because it's not about the x, it's a power raised to a power. That's a property of my exponent. Power raised to a power means I multiply. So we get 4 times 3n. 4 times 3n is what? 12n plus 8 over. A lot of you guys made this mistake. What's 5 times negative n? Negative 5n.
Oh, yeah, totally. Oh.
So be careful. It is a power raised to a power. You multiply. Now, same base. What do we do with the exponents? When we divide.
3 to the power of 7 and plus 8.
Almost. So close. I think I overlooked this. But be careful. What do we do when we have this
You subtract.
subtract? So 3, 12n plus 8 minus negative 5n. I'm running out of room. What happens when you subtract the negative? You add. 12n plus 5n gives you what? 17n. We'll move it over here. So we got 3 to the 17n plus 8 is equal to 3 to the 4th. Okay? Sorry, I ran out of room. 12n plus 5n gives me 17n. We have the plus 8. We haven't done anything with the 3 to the 4th. Now, we have the same base. Single base on both sides. What can we do?
N plus 8 equals 4.
Nice.
17, 30.
And then subtract 8.
4 minus 8 is? Get a negative 4.
Yeah, that's what I said.
How do I get rid of the 17?
Wait. Divide 17. We have a question.
N equals negative 4.
You divided the wrong way. Not 17 divided by 4, divided by 17.
Okay, wait.
8.
Yes.
So it's this one.
It's all good. Negative 4 over 17.
We got it.
Yeah, but I'm in parentheses. This is plus parentheses. Plus.
Because what this originally was minus a negative 5n. Because you subtract the exponents. So minus becomes plus.
So it's plus positive 5.
Yes. All right, now, I will tell you that problems like number 17 and 18 are about as hard as that we're gonna get without involving the next piece, which is logarithms, okay? Because there are some times where we cannot change the base to have the same base. Okay? There are going to be times when that is not possible. In that case, we get it out of an exponential and we use the next function, which is going to be a logarithm. We're not going to get into logarithms this year. Okay?
Dang it.
Now, what I do want
Missed that. I wanna know how to
Don't erase, don't erase, don't erase.
is not an algorithm, a logarithm.
I wanna logarithm though.
I knew how.
I forgot my.
All right. So, there we go. All right, you are going to need your device, your computer, your tablet, whatever. This one is not posted on Classroom yet, okay? Because we're going to do it live.
No, wait, don't erase, don't erase.
So, if you go to the join.quiziz.com, which is that right there, and you put in this code, okay? So join.quiziz.com and put in this code. We're gonna solve exponential equations.
Okay.
We'll see how good you guys get. I want to see good stuff. Good stuff. You got plenty of time. There should be plenty of time for each. Code is 590342. Can I erase this stuff in the middle so we don't get it?
Yeah. Okay. Join quiz.
Those are.
I will be last.
I know, I should have done one day, I'm so done.
Come on, you have to keep it. This isn't fair.
I'm sure,
Come on.
It's asking me to buy quizzes.
I'm a turtle.
Oh, wait. How do I?
Oh my God.
We need to do something.
we need a point to that.
No, like, this is how you work. This is how you need to do.
Why is everyone not here?
Go all over here. When you know, stop right now. And then just like, which one do you want? And become what you really want.
Não tá aí essa.
That's how it works. You don't need it.
Eu não sei esse site.
Dali, ó, join those quizzes.
Yeah.
Don't go for that.
All right, let's go.
No.
Hey.
I don't know. I'm ready.
Hey, live the second one that joined.
Well, at least we're doing something. That's good.
Wait, can I change?
I see. I don't have any choice over the picture, sorry.
Mine looks like it has rabies.
This is rabies, come on.
Oh, shit.
Yeah.
Yeah, so
That's all right. So does the owl. Yeah,
Oh,
You're the cockroach.
yes, sir.
tired. No.
Ladies.
Lower all.
I don't get what you mean.
No, it's like 150. It's like
4, 7, 10, 14,
I'll just
15.
because I.
Oh, we have so you have to do math.
Do we have to do math? This one I didn't put any non-math questions in. Sorry.
It's good, because this will be last.
Okay, here we go. Here we go. No, you're not.
No, I wasn't ready for this.
Settle down. Here we go.
What? I didn't even know.
I will tell you with your phones, you have to be careful as you scroll it.
Yeah, you saw that.
I got one right.
What is it?
Well, I got none right. Yeah, I got it right.
Oh, it's going already.
They're giving me one.
No.
I'm right. Second.
No, I got nervous later. Oh.
You're a woman.
Is there?
Hold this on, mister.
Oh, jeez.
I have 0 points.
Yeah, what is my lucky number?
Not too lucky, guy.
What?
I'm 50-50 right now.
That's it.
Oh my.
I got
Yeah, we're
it.
gonna copy it. Whoa.
Oh, that's correct answer.
I'm not so sorry.
I actually did.
I don't do good on the.
No.
I'm 3 5.
Take your time, guys.
Hey, someone had a question for.
Halfway
I'm on
done.
50.
And
I'm on
we're
50.
Stop, Louis. I'm getting your seat over to you.
You guys have plenty of time. Like on each one of these, that's like a 5-minute time.
Ow.
Fine. Slow down.
I got it.
I don't even need to do it.
Oh, I got one right.
Over 6.
Yes, I look from him. I got 3 in a row.
Thank you.
I'm over by right. Let's go.
I got the other people.
I'm 8 and I'm just 6.
That's good. We're better correct than we are. Oh.
Sorry, Seriously, how many behind you?
Yes. 3 in a row.
I got one.
I got it right.
Oh, wow.
Those are connected too.
I'm
What a
No punch fast. I'm never named.
Nice. 50 to 41. That's good. That's
Woo! You're getting it right. You can write this. Okay.
Alright, hold up. Jesus, turn it on. Yeah. Oh, it's dead.
Your phone.
I'm still
It says I'm ranked number 1.
No.
I'm halfway.
And or.
I
didn't do it.
I got X equals 23.
Right?
That's not what I nailed it.
Let's do that. That's good.
Oh, there.
I'm in 3rd place.
And 3 to the power of 5.
I'm in second. Who's by now?
Sorry, I have a check.
4 to the power of 4. You say you can.
I'm second.
I'm first.
How did I get 3 at the top?
I got Ron's
7 in a row. Oh, bring it one this time. Banana King Sky Phone here. I'm gonna have to buy. Is there any way of putting X?
Or no, you can't solve it.
So now, mysteries.
8,800. 8,800.
Oh, I'm ranked 6.
I will say that
My live rank is number 1.
Will do.
last month got a perfect score.
Wait, someone got a perfect score?
Yeah, I was quite impressed.
Ah, halfway done, Jesus Christ.
Can I stab your fingers?
Finger that.
What the hell?
So I'm just gonna say that the first 10, I did like guessing, that's why I flew back.
Did you do it better now?
Yeah.
No.
So I'm not guessing.
That's good.
No, not in fifth.
Trouxa. Eu don't know that.
Wait, what are you looking?
Think I'm on the same one.
I'm very happy.
Again, this question again for me?
I'm in third.
64. We're gonna do this again.
Mano, olha.
She's igual 6, she's igual 10, she's igual 24, 5 e she's igual 10. 60% accuracy.
Wait, no.
Can I
35% accuracy. 50% accuracy, level rank 5. 5.
That is your random.
I have a 25%.
Are you ready? What is this?
Come on, put everything's folder. Let's go. We're gonna get this one.
Eu sou o oitavo de 6 mil e o Bruno tem 2 milhões.
No, like this.
Não, é você ver this?
No. Why is there no way?
Oh.
É 12.
Oh, yeah.
É 8, 6.
How much is this?
Meu Deus, muito bom.
Yes.
Alguém já fez esse?
I know which one it is. Minus 5.
Maya fez esse.
Minus 5.
You're really good. Third. So he has to get this one. Thank you.
No.
Yes! No, those are past me. You were like 50 points behind.
I was looking for
100, correct. What?
I don't care. I'm both.
Oh, I love you.
No, wait, Luca, where did you fly?
I'm in fifth.
I think noise is sacrifice.
That's it.
7 in a row.
I'm gonna bring it back.
No! Come on!
I can't.
All done.
So what?
No.
Oh boy, calm down.
I'm in third.
What that?
I'm in third.
Yeah.
I'm in third. I'll take it. Wow, only 71% accuracy.
I'll change
Yeah,
that.
probably because I'm
Accuracy is
half
35.
I missed 3 of them and that gave me 78.
I missed one. Oh, of course. Wait, what did you?
I'm gonna play some pinball, okay? While I wait, I play some pinball. Good, hey! That's two! No! I tried to rush it.
Got the first 3 wrong.
Okay, if you were. Nailed it. You're cheating.
Which one?
I'm so glad you listened to me.
I left the message on the table.
48%.
Chris said you just like 500 seconds. Needed should be a thing.
If we get this correct, yes, I won!
How no?
Yes! Drew got that is 40.
What's the name of the? What's the name?
The one that missed was so
I lost.
I'm gonna get all of them.
Quando esse aqui, velho, eu não você.
É, muito.
Three in a row.
No, pues, what's it is? Yo dije,
You don't know my age. I'm 21.
Oh, no.
Let me enter my age.
I could.
Mr.
I play pinball.
Not for that long, but I could do it.
Mr. Easter, do you teach,
Not like how.
Standard for 10th graders?
I don't teach any 10th graders.
It's a keep mind you
I teach 9th and 11th.
Oh, I know, I need to go out. It's not.
You're a dude.
Well done.
I'll teach you standard for 10th graders.
57%
I don't know.
accuracy.
Yo fue muito idiota.
Yes, sir. I don't know about next year.
I wanted to.
Nice job.
I'm a four. I went down in rank.
The one they missed was.
I went up
Okay,
here.
that's good. All right, so I tell you what, this is what I'm gonna do with this.
Yes.
I will go live and it went through. What I will do is I will post this again on the Google Classroom, and I will scramble the answers, scramble the questions, maybe add a couple in there. I know it's gonna be a while since we see each other, before we see each other again.
Oh, Mr.
We
Don't
got
cry.
class trips next week. So I want you, maybe on next Friday, Saturday, or Sunday, or Monday, any of those days, take and redo this quiz, just to keep it fresh in your mind.
They're gonna cry.
Am I gonna cry? I don't think so. Okay.
I would.
I'm not a rainbow keeper.
I have